Evening, folks. Thanks for joining me tonight. We're going to finish the assembly and testing of the Lafayette Explor-Air regenerative receiver. So, to keep this within something somebody could possibly watch, I did the assembly of this radio over the last couple of nights and filled in segments as I went along. I think all told, off and on, I spent about 6 hours putting this together. At the end, I think you'll see it came out quite nicely, and we'll test it together and then actually try it out. So, just to show you some of the detail, the assembly manual you get with the radio. Now, we went into this in one of the previous videos, but at some point past that mechanical assembly here, which we did in the last stream, we then get down to business and actually begin to wire up the radio. And that's where really your attention to detail comes into play. So let me head off to the first and second segment, and I'll talk more about that. So we just started the wiring of the chassis. This picks right up
from the where we left off last Sunday. So we've already taken the time to put in the first few wires through here. Just wanted to show 2-3 things that I'm doing to keep it nice and neat, build it well, and also make some improvements along the way. So first, we're using this nice NTE solid wire all the way through, and the nice thing about using solid wire, which is really it's called for, is that as soon as it's soldered into place, it's pretty much going to stay put. We're going to be able to push those wires down to the chassis, essentially use the chassis as something like a local shield. So instead of it kind of floating in the air and picking up, say, rectified AC from here, the 120 AC off of this switched power pair here, that we can keep those signals quiet, which is really likely the intent of why they have the set wired in the way they do. So in the instructions, they talk about there being specific lengths. Say, for example, cut a red lead to 2 3/4 inch length and connect to pin 7 of a socket, something like that. I'm taking those as informative. What I'm really doing is that I'm taking the wire, which I have off to the side, and just kind of manually dressing and running and seeing kind of roughly how long it ought to be if I'm going to come in with a nice neat routing like I have for here. Some came just about where they're called for, others don't. For example, there's this green wire that comes off of the volume control here to pin 5 of the tube socket here. So the originally called for 3 and some change. I made mine longer because I suspect some of the issues I was having with hum previously had to do with some lead dressing, particularly what they recommend, which was to take this lead and kind of run it right between these 2 other leads, which I expect will be carrying 120 AC. And that lead is part of the input for the audio amplifier tube, which is this. So instead, let's see what happens if we route it out first, then down, around and close to the chassis, away from this AC wiring directly to that pin there. So that came in a bit longer, but in practicing the dressing with some scrap piece of wire, I was able to come up with pieces that comply with that. Second is how I'm approaching putting the wires into the terminal lugs and sockets. So in general, I follow the example that was commonly given in Heathkit manuals. Essentially is to take this wire and straighten it up. Here's a red wire. So now that I've bent it 2 or 3 times, I'm not gonna actually put this in the radio, but it kind of, they recommend stripping the wire end about a 1/4 inch. I actually kind of let the part tell me. So I'm going to put a wire here, and I really always want the wire to enter from the middle and then the lead to wrap around it. So this lug has a little bit of thickness here, so I need to make some allowance. So I actually stripped my wire back about 1/2 inch, and what I'll come in with is a pair of needle nose, and I'm going to set that where the insulation's back about 1/8 inch. And then what I'm going to try to do while working on camera, and this is why I have to pre-record, this has turned out to be very difficult to do while having a camera right above the workpiece. what I'm going to try to do is bring it around about the part where it's going to wrap back on itself. It depends. If I'm doing a tube socket, I really do want to cut that a bit shorter. I'm not, so I'm going to cut this where it starts to come back around on itself. And cut that piece there. Put that back where I expect it. And then crimp using the needle nose. And what I should get is one full turn, one full loop around the side of the lug on this terminal strip. Like so. And we have a really sure mechanical connection. It's going to stay right there. So then from there, I can push it down. I believe this is supposed to go to this tube socket here. I can push it down and begin to route it. So, like so. Now I have this already built and wired for the tube socket pins. I find while it's easier to put these in straight and bend them around, for these more fragile tube socket pins, that pre-forming a loop works out better. Try to get them where the loop is just an open U, like that. And you can insert that straight because these particular terminal pins on the tube socket have a very large kind of sewing needle opening, and then turn the wire loop 90 degrees. So now it's facing more horizontally, which I'm sure you could see nothing of. So you can see there, yeah. And then finally, I'm going to come in. Let me just turn this off. Just come in and close the loop again. What we're shooting for is a good, robust mechanical connection. I do still want to be careful about not tweaking particularly these more fragile tube socket pins. And then finally, I'll go in and dress the lead how I want. Now some of these just call for them to be not soldered for illustration. So have that nice neat kind of layout there. From here I'll start soldering the wires as needed. There and there. And just kind of, as I'm going, the color codes do help. I'm also thinking about what's getting exposed to what. So I have a pretty good guess that this yellow wire is the filament circuit because it goes from all the way over here to here. I'm sure if I looked carefully at the pin assignment for it, I'd probably find that to be the case. This must be the input lead because it's coming off the wiper of the potentiometer, so that's going to be a low signal. And this red is the B+. That B+ should be pretty well filtered. So laying that near the input's not too bad. This filament being kind of nicely routed away over here is pretty good. And all of that's away from this 120 AC pair over here. So as I go, I'm just trying to keep in mind what each circuit is doing so that I make sure to keep it as clean as possible. And we'll just keep wiring from there. Next video you see will be this wired all the way to pictorial number 3.
Okay, so I'd gotten just started in that video, And so we have 10 segments to go through. So wiring is underway. I'm going to head to the next segment where I'm going to talk a little bit more about layout and component installation considerations.
As I install each of the wires, I'm taking careful notes against the assembly manual. So let me show you how I do that. So what happens is that we're connecting a wire from one point to another, and depending on what they instruct, we're going to add solder or not solder. So there should be specified length, color, pin location, I guess a socket, whether it's soldered, and then finally the other side, pin, socket, solder or not solder. So after I install that wire, it's just mechanically fixed in place. I make sure, double check each point. The length is okay. If I look like I have a routing that looks like the pictorial, it's fine. Then check the color again. And be very careful, check the pin and the socket it's supposed to connect to. And then do the same for the other side. And then after I'm confident, I'll come in and apply solder if it's called for, and just note that it's not soldered, and then finally cross out each of these sections and check it off. And then one by one, from we start at number 23, work out to 51 before we get to the next pictorial. Actually, no, it's 36.
Sorry about that. I have a lot to learn in video production for sure. So I'm going to head to the next section where I've gotten a bit further along. My apologies for kind of messing up the transitions there.
Okay, so we've made it through the first page of assembly, which covered both pictorials number 2 and number 3, and about half of the wiring. So since the last video, we have a number of connections between the main dual triode, the beginnings of connection for the rectifier, and a lot of the B+ connections between the 4 coils. So some points. The rebuilt electrolytic capacitor, the multi-section with 30 microfarads per. That routing is pretty clean. The insulation is quite flexible, but it was able to take a set with putting some real tension and then using the needle nose and then pulling it. This connection to the rectifier here does really need a loop to come in and not block access to some of those other pins. Where it was appropriate, I routed wire up in the corners or as close down to the chassis as possible for the connection of the B+ and B-. Those are floating loops. It's really indicated in the manual as well. Again, a lot of these, I took the lengths as informational and then really just ran the wire along the lines of what the manual called for, but cut to length. One last thing to show is how things turned out with connecting to the antenna capacitor, just right there. So one plate, I believe it's the rotor that's connected from this middle pad here, the wire down to this, and there should be later on in the assembly a capacitor going between here and here. Now forms a series capacitance circuit that should replicate what was originally called for. So we're doing pretty good. I might add a zip tie here and here, but what we'll proceed with is the assembly for pictorial 4. That does some of the top of the chassis wiring between the speaker, the two tuning capacitors, and then proceed with the wiring of the band switch. So what we'll be emanating here is quite a few blue wires connecting to each of the band coils and placing them as inputs to the one section of the triode. Okay, see you for after we complete pictorial 4. Okay, so we're getting pretty far along. I'd say we're about 2/3 of the way with the wiring. We haven't installed any electronic components except for what mounts on the chassis. So we're looking at the top side when we've just wired the two tuning capacitors, the main tuning and the band spread. And we have those two floating wires going there, and then to the two sections of the main tuning. And it's a little neat bit of neatness. The twisted pair for the speaker is bent and runs along the rim of the step of the frame, then down to the two terminals. Turn it over. And we're starting to wire up the switch. You have some of the wiring for the regeneration control, as well as the selection of the two sections of the main tuning capacitor. So what will happen from this point on is a lot of this wiring for these terminals here going for selection of the tuning coils and the ticklers. Okay, so we're getting pretty far along. I'd say we're about 2/3 of the way with the wiring. We haven't installed any electronic components except for what mounts on the chassis. So we're looking at the top side when we've just wired the two tuning capacitors, the main tuning and the band spread. And we have those two. Okay, so we're most of the way through with the wiring of the chassis. We're going to be...
Oh boy. It really is a learning process for sure. So looks like I loaded the same video twice. So we'll skip ahead to the last bit of assembly right here.
Okay, so we're most of the way through with the wiring of the chassis. We're going to be moving to installing the remainder of the components here, and the last bit of wire to the band coils here. A couple of things I want to note. I see a lot of solder joints, and they're perfectly fine solder joints. They'll last to the end of time. But I want to try to keep my lead lengths as short as I can, so I tend to take care to bend over the loops and just touch enough solder to make a good solid joint, but not actually fill out the hole in each of the components. Maybe I will in the tube sockets. They're rather narrow. They're built like a sewing needle. But these large holes here, it doesn't really no sense to just keep gobbing solder on and on and on. What that allows me to do is to do some really fine soldering work and run wires in the shortest path possible, including this yellow wire
that goes to the antenna capacitor here. So instead of having to bring it out and then back over again, I'm actually able to route it between these terminals here on the switch and not have it burn. So we're just going to continue. I'm at step 74. This is 105 steps, so 3/4, we're really an hour, or 3/4 of the way through the assembly, and I'll see you at the end. Okay, it's 9 o'clock, Saturday before the stream, and I've just finished wiring up the radio. Went through all 105 instructions. I did pull the tubes back out so I could tilt this over for you, but all the components are in. Some items. Wherever there's a long run of component lead, I put heat shrink on there. Wherever it's just too short, I don't bother, so that there's no heat shrink that jams up into the solder joint. All nice flame-proof resistors. Mica caps for the low values, poly caps for the high values, and the special AC safety capacitor right there. So to show you, now this is, it's not a beginner's kit, but it's, you know, it's for something that was intended for even young teens to put together. The amount of detail that you have to put in to make sure you got the instructions done correctly. That's the right color lead to the right part. The light position pin, and to remember, don't just go ahead and solder it. Some points have to be left unsoldered until later. I was just thinking about this. So the radios that you can buy that were built as kits today were the ones that were successfully put together. But how many successfully got put together? Now I've just gone through this. I'm not inexperienced with putting electronic things together, but I found it, unless you had the right space and tools, you were trying to do this in a kitchen table, mom's not trying to say, hey, go take that somewhere else, it smells, that I'm going to say roughly, you know, it's possible that many of these kits that were sold were miswired. And of a few of those, they got resolved, or maybe got sent back to the factory to help get them resolved. But I think many of them didn't make it. That it's a small amount of ones that were put together poorly but happened to work, or got shoved in a corner somewhere and went through at least a couple of hands of people who bought them at a ham fest or something like that. Only the ones that got put together well survived the most often. They were frequently changing hands between collectors and new hams and the like. This is something I've just noticed, and it takes very careful work to put something like this together. And it's only the folks who carefully put things together that we get to work on radios like this and do something like rekitting it today. So if we remember put this together, I don't know who, other than that they lived in Massachusetts and bought it as a kit and put it together themselves. And the worst problem I had was with this antenna tuning capacitor, because that was the whole structure I found tacked onto this, which was a standard tuning capacitor built off to the side to try to fix whatever problem happened with that. Everything else was put together well, and with a temporary replacement electrolytic, it worked well enough. So I'm going to leave it for tonight. You folks in
the video segment that comes right after this are going to see whether this radio works. Have fun.
Okay, finally got that transition down. Nice. We're gonna play a little bit of a time travel game today. So here we are. We've just come to the end of the assembly. And in the manual, they say, actually, what do they say? Let me go pull the manual out. Let's see. Install antenna. Be careful. Well, at the end, after you've installed everything, you should have something that looks like this from the top, which, Mike, if you're on watching the stream, thank you so much. These are your 3 new old stock tubes right there. Everything's installed there. I have a little bit of an antenna ready to go. Actually, before I unplug it, before you do anything under that chassis, let's flip it over. Okay. So here we are. It's upside down from the view you saw through the series, but that does give you a little bit of a better edge view on how the components got installed. There's that filament dropping resistor, the 3-section electrolytic filter capacitor, and some of those components there, and there. It's not too bad. Some places I would have liked them to be a little shorter. But nothing looks odd, and I just did the shake test, and all that came out was this little bit of, no, right back in. Hold on, shake test that back out. There we go. There's no little bits of leads hanging out in there. On the front panel, turn this back around again for your benefit. We've installed the knobs. Look at those pointers. They turned out very nicely. Let me take one off so you can see what we ended up doing to make that pointer stay on. That was about there. So we got these, as you saw in an earlier stream, laser cut out of acrylic from, I think it's Koya, but a laser cutting company. There it is. Shows up very nicely. And what may have worked a little bit better would have been to push this out of the way. Perhaps glue it or double stick tape it to the edge of the knob, because the skirt has a surface. There you see right there, that edge. I didn't do that, so I needed to glue something to the hub in the knob. So I had a set of 3D printed spacers, which you also saw as a design in the earlier videos. And using a special epoxy that's meant for plastic, it actually seems to contain, at least it smells like it, methylene chloride, some really nasty plastic melting stuff. So it acts to really key into the plastic, essentially by melting the surface. Now, this is made of bakelite, so it's not going to really melt. So thermoset plastic that's very highly chemically resistant, but the acrylic certainly does, as does the ABS that the spacer is made out of. But it seems to stick well enough. And as a set, that just looks real nice. Let's put that back. And all the other knobs are positioned. I don't think any of the controls have D's on them. These are where there's an actual flat on the shaft to enforce that. Maybe this actually has a D position. One thing I found that was a little lacking is the length of the shaft for that polyvarican-based control. That was a machined part that I got from from Mike's Electronic Parts. So unfortunately, with the whole stack up of spacers and the PC board inside the chassis, the shaft that sticks out is not quite long enough. So this knob is barely on there. One thing I'll ask is one of my machinist friends to make a slightly longer version of that, and that should completely fix it. Everything else seemed to go just fine. But it's the moment of truth now. So I'm going to stand this up because I don't think anything on top is going to smoke. Goodness, I hope not. And if it does, it'll just roll over the edge of the chassis. I'm going to prop this up for you folks, and we'll see what smokes when I turn it on. These are flame-proof resistors. Let's see if that holds. And I'm going to make sure to keep my hands away while I do this. I'm going to plug it into an isolation transformer power strip here. And let's turn it on. I'm not crossing my fingers. I think it's going to work perfectly. 3, 2, 1. What we should hear in a few seconds is some light hum coming out of the speaker. It's coming. Ah, there it is. All right. Okay. Oh boy. Woohoo. That's good. Okay, what does this tell us? So we're hearing just the lightest hum. I'm told this is expected. Given how this is laid out, I'm not going to point at it with a screwdriver. That doesn't seem smart right now. Let me point out with this little red piece of plastic here. So we have this AC filament drop circuit here. This is the 50C5. It's the audio amplifier tube. But we also have some AC running here. And there's just, it's not the cleanest audio output design. So there's going to be some hum. Plus we really didn't change the values of the capacitors here. We didn't try to optimize the filter. So a light hum's not too bad. Volume's all the way down. So we know that, thank you. There's no major issue. I'm not feeling anything hot. No smells. That's good. Let me turn the volume up. So there's a hum. If there's a hum and that took time, that means that the filament circuit is working, because this is a series string. So all the filaments of each of the 3 tubes are all connected together. So if there was an issue with that, and there was no current passing, then we shouldn't hear a thing, because you're not going to get any amplification, any hum, without some filament operation. We know that the B plus is doing something. We know that there's a high voltage to operate those tubes, because we're getting something of a hum. And the only way that's going to happen is if there's some current. Thank you, Sarah Joy. And it's a good guess that audio amplifier circuit is working somewhat. Let's see what happens if I turn the volume up. Okay. Volume control seems to do something. Turn it up. So what you don't see is over here, magic fingers are turning up the volume. We hear a higher pitched hum. So it's That's due to the, that's likely due to the rectified AC, the kind of ripple that's on the high voltage bus that operates, essentially is the source for operating the tubes. So that's okay. Let's see, I'm going to set the band switch to A. Oh, okay, cool. Turn that down. Something happens when I turn the band spread and the main tuning knobs. I'm going to turn the antenna tuning knob now. Oh! Awesome. I'm going to get something. Come on, I need to use see this. There we go. So magic hands are here. This is the antenna tuning control. This is the band switch. This is the regeneration control. This is the one that controls the positive feedback in this tube here, which really does all of the work. And then finally, this is the volume control that sets how much audio goes into that 50C5 audio amplifier tube. So I'm on band A, which is the broadcast band. I do have an antenna hooked up on the just a short 12-foot wire. Let's see if we can get something. Okay, so I want to listen to an AM signal. Turn the regeneration to just short. So if you have headphones, if you have them turned up, be careful, because if I start popping in and out of generation, it's going to possibly be loud. Not this time, but you just get this. It gets a little louder, a little louder, a little louder. And you get this kind of rushing sound. So this is, I'm going to turn the regeneration control all the way down now. So there's essentially minimal gain in that stage here. That minimal gain means we're not going to really pick up too much except for the stronger signals. And it's a 12-foot wire. I'm on a slab house that's set into the ground, so we're not going to pick up anything, I think. And still, no fragrances. This is good. Okay. That's a rush. Okay, leave it there. I'm going to turn the antenna tuning control. I don't know, that position, it's almost like 10 o'clock. Seems okay. Now I'll turn the main tuning. I sort of hear something. Turn the regeneration. Okay. Huh. I hear audio. It's not clear, but you know, and then again, I didn't expect very much off this short wire in the basement. You can hear, you want to pick up an AM signal. You want to get that regeneration control just a little bit before it starts to whoosh, because that's feedback going on. Right there. Okay. Wow. All right, I'm going to turn this down and we're going to go see what's going on topside. I'm going to be very careful as I do this. Please don't shock myself. Thank you. All right, what I'm looking for is just to make sure that the tubes are happy and healthy. You expect them to, they're little light bulbs, so they're going to have some heat to them for sure, which we do feel heat off that 50C5 and the 35W4. What I'm really looking for is to make sure that the plates, which are the parts that we can see, or at least we see the outer section of the plates, that they're not turning red. I really don't think that's going to be the case, but if you really get something wrong with how the tubes are installed, or what's termed biased, then you can observe an issue. So no, everything looks fine, and they're all operating, like I said. This thing really wants to receive. You know what? I think we built it right the first time. That's great. Oh, geez, this is really nice. And it just looks really sharp and new, except for that little spot there from corrosion. Just really looks like new. And I'm going to go underneath again. Now this is live. Just to be clear, it is live and kicking right now. Some really unfriendly voltages I'm going to stay away from, but I'm just looking to see whether any parts are changing color, particularly the resistors. I mean, things like the capacitors, as long as I haven't damaged them, they really cannot conduct. At least in the receiving circuit, they're not going to conduct excessively. That tiny electrolytic capacitor right here is in one piece. Yeah, everything looks great. So I'm going to turn it off, and we're going to put it in the case. See what I can do to show you this. All right. So there's the solid walnut case. I had this made by a local artisan who typically makes jewelry boxes. I was very busy this season. It's a lot of orders for them. But a nice 1960s radio, and I got this sort of style from these old radio receivers that were sold in the early to mid 60s by companies like Acoustic Research and KLH. KLH, among their many products, made a really nice suitcase complete turntable set. I think one of our viewers has one that I've worked on before. Okay, I'll turn this up. We'll set it in the case. There, and there, and there. So, just prop it up like so. And let's put those cap screws. Again, in case he's watching, and even if not, thanks Mike, analogdial.com. He's not in the business of providing parts for this, so don't bug him. But if he is a friendly, helpful guy that convinced me to make this a project from his great write-ups and in narratives and pictures, so do check that out. So we have the very small round-headed wood screw and cupped washer, so we don't excessively mar up the finish of the silk screened panel. Number 2. Wow, this is going to be great. move it forward. You know, when we move, I'm going to look forward to getting a little bit more space to light this, so you don't have to contend with this overhanging shelf. Okay. Here we go. All put together. Still plugged in. Be careful with that. There's the radio in a brand new walnut wood case. Look at that nice walnut finish there. I'll actually show you the back too. There's a nice area down here. That's the antenna port. Looks like I'll just have to. Yeah, that got a little stuck in there. It's okay. Headphone jack and the cable coming out here. You can still get in to access the tubes if you need to replace them, but your fingers are mostly kept away. I don't know if there's any unsafe voltages in those parts, but it does block up the bottom and properly space it off the chassis bottom as well. Let's plug it in, give it another try. Let me hook up that antenna. There we go. Let's turn it on. Let's listen for that hum. So here's another thing I noticed after I finally got this all put together with the case. My pointers are just a bit long. Right, just like a 1/16 right to the edge of the case. Got a little scratch. So since we're down here, we're not going to pick up too much. And if anything, we're just going to pick up the noise off the power supplies. Let's give bringup a try. Maybe we'll get lucky. This is that famous magic of regenerative tuning. So you have to play with 4 knobs, right? You don't want it over-coupled when you antenna tuning. You don't want it too minimal. you want to adjust the regeneration appropriately, but that regeneration control doesn't hold true across the whole band, the whole main tuning range. The amount it's regenerating changes as you tune this, so then you have to keep going back here. So now it's out, right? And it also depends whether you're touching the knob a little bit too. And finally, if you find something, you can do, maybe I'll set that to 50, do fine tuning using this. Not finding too much. Go back to A. Oh. Okay, so then, let me just turn this off now. So I've played a little trick, because I kind of knew that we'd have a bit of a problem recording video and getting good reception off a radio like this. So it just looks off of some floating wire. Which makes it a lot more sensitive to interference coming off of the switching power supplies used in the video equipment as well as the laptops. So what I've done is I had already tested the radio. I wanted to know I wanted to know if I was going to have to do several more videos about how to fix this, but we really got quite lucky. We did prepare, and in the end we were able to build the radio seemingly correctly in the first try. So I'm going to run 3 segments where I've taken the radio upstairs where it's up at least 10 to 12 feet off the ground. Ran that same wire, and we'll listen to a couple of things I picked up off that little short piece. Hold on.
Regen, and now today's market.
Computercareer.edu. If you plan properly for your retirement, you should have enough money to cover your income needs. If you don't, if you hope to live comfortably. Hi, this is Chuck Zada from the Armstrong Advisory Group. Generating retirement income tends to be difficult, which is why it couldn't be more important to have a retirement income plan.
I gotta take a break, but Linda, I'm gonna let you go. Thank you for your multiple suggestions.
You're most welcome.
All right, you take care.
Good day.
And happy 24.
Okay, so in that segment, I tuned two different bands. One was over here, and that gets, let's see, that's 1.7 megahertz to 5 megahertz. So the lower part of the shortwave bands. And off the bat, we listened to some program from WWCR. Later on, we tuned around, switched to the A band, and that pretty much covers the AM broadcast band. And we heard some local broadcasters first with some financial planning, and then ending with the Little Drummer Boy playing in the there. You may have also noticed that off the side that the antenna was waving around. It just had that wire running up and tacked onto a little corner of a sliding door. When I noticed along the way that sorry about that, that the antenna tuning for such a short piece of wire, that if you listen to a signal, particularly one that requires very fine tuning, that walking near that antenna would actually pull that tuning quite a bit, which probably means that this control needed to be adjusted just to decrease that effect, I think. I'm going to go to two more segments where we've moved it over to our record playing station. Let's see how that sounded.
To believe that positivity so many times has been used by you to remind me and everybody else, not only has it been given unto me and to others to believe on Christ for Christ's sake, for his cause, but then to suffer.
Casts. So Susan, let's do one more real life story. I gotta tell you, this one may top the list of real life stories for me, because it deals with gifting and it deals with estate taxes. Obviously the guy deals with estate taxes and talks about the importance of them, but we always mention how nothing good comes from giving assets away.
Right.
And when we say nothing good comes from it, this is a prime example of nothing good comes from it. In fact, I never even thought of this issue arising until this case walked in my door. So let me tell you about it. The 84-year-old couple comes in. First of all, 84 and wanting to do estate planning, you know, I'm happy they're doing it, but...
Okay, so we've had two segments. That first one there, I don't know who was broadcasting it. That's for anyone who's listened to shortwave, the guy is rather infamous. That's Brother Stare, who is transmitted around the world from his home studio, or I guess his compound studio in Walterboro, South Carolina. And he's the oldest Bible beater I've heard. He's still going. I was to listen to him with my roommate, who was a Christian amateur Christian apologist. But the study of the Christian scriptures and understanding the logic behind it. That's what she was really into, and we used to listen to him as a great joke. Anyway, so we listened to that, and that came in really nice and clear. And then second was back to Band A, AM broadcast band, again listening to financial programming. I think there's a station in the Eastern Massachusetts area that just broadcasts financial planning as kind of a 24-hour commercial for the planning services offered by that company. What is it? Money Matters Radio, I think is what it's called. Well, we made it. After 4 long sessions, actually the one that took the most work is the one that's our shortest video for this whole series, that we've started with a radio that came rather forlorn out of an attic, bit worse for wear, and we did something you typically try not to do to a radio. It's not always the best. It's often not the best thing to just take it completely to parts and back unless you fully commit to the whole project. And in the end, it could cost quite a bit. The wooden case we see here was not cheap. It was made by a local artisan out of solid walnut. You had to go back a couple times for some refits. Modern knobs. These are all replacements here. The machining, really the PC board adapter is likely for me the cheapest part. I think that cost me all of $15 for 3 of those boards. And then the whole mess of electronic components, which I'd show you, except we've already packed them up. I think if I really count it all told, there's over $150 at least in this radio. In the end, what do we get? We have a fascinating piece from the 1960s. It was an early, rather inexpensive kit. Really, except for the wiring and the components, there's not that many parts to it. Some of these radios, if you didn't want to have a speaker, you could just have headphones, and that might be only one tube. Or there'd be 2 tubes. One's the one for making the DC out of the AC, and the other is what's here, the 12AT7, the one that does all the work, gets the signal, positively feeds it back on itself, and then produces the audio from that modulated RF input that it sees. As a radio, it's definitely for beginners. There's so many complex things when it comes to that fundamental way that it's saving you money and time. When regenerative receivers were developed, the state-of-the-art, I went through this in the first video, the state-of-the-art was tuned RF sections where you'd have one tube, you'd have some gain, and you essentially selected what station by tuning each respective section. You'd have to have multiple sections because the gain they would offer wasn't very much. It'd be in the single digits. With using positive feedback, you can get gain from what's a minuscule signal to something that could actually be heard on headphones. It's a gain of hundreds to tens of thousands of times by adding positive generation. So for the problem they're running into then, how do we come up with a more efficient means of using these tubes and not have one tube just to get a little bit of work out of it? Because they certainly were very expensive in the 19-teens when this when the positive regeneration was developed, that you could look past some of the difficulties. And what are some of the difficulties? Well, so one tube is doing all the work, but it is highly sensitive to what's going on around it. So as you saw, there was a lot that depended on the setting of this antenna tuning. In fact, when I've done some receiving of Morse code signals with this, which you usually just have the generation just a little bit northward, just starting to go into feedback, you could actually do fine tuning using this antenna tuning control. So it's actually pulling the tuning frequency, the tuned frequency you're at. And similarly, if you adjusted the generation control, it would do the same thing. So if you're trying to, sharpen it up, you would also find it would start to retune it. So it's already quite a bit of complexity there. And then add that as you tune across the bands, even in the AM broadcast band, which really isn't that large, that the amount of regeneration that is applied is not constant. So as you move this, you then have to move this, and you may have to move this. In fact, you may have to do this and this and this, and then sharpen that, come back again, do this again here. And that's just the gross tuning. Then you have to come back with the fine tuning here. And the fine tuning, that might not require so much adjustment, but I do find often it did. If you're listening to AM signals, what are AM signals? Those are amplitude modulated, so anything on the AM broadcast band, that's all amplitude modulated. Shortwave broadcasters, they're almost all amplitude modulated. Those signals are fairly wide, so tuning them here I did not find to be too bad. If you're trying to tune in signals which are considered smaller, narrow band, so that would be if you had this set, you would hear some funny Donald Duck voices. That's what's called single sidebands. You can tune those if you just add the generation like you're doing Morse code, just a little bit into positive feedback. I found it very difficult to tune. I think it was Mike's radio that he built when he was a kid that he replaced this band spread, which is essentially a fine tuning control, with an even what's called a vernier. So it mechanically reduced the amount of rotation for how much you turned the knob, so you could get really fine tuning. I did even try to use this as the fine tuning, but I found even that was too twitchy and sensitive. So as a receiver, I think if someone tried really, really hard and essentially they parked on frequency, you could sort of use this for ham radio. There are people who have used this for ham radio, at least as a beginner's receiver, and it can be done as a way to listen to broadcast. That worked out quite well. And listening to broadcasters, now that they're essentially none broadcasting to North America, you're just listening for signals that are coming from North America going out. So receiving those isn't too bad. And occasionally you do get some foreign language broadcasts, like I think I was listening to something Japanese yesterday. Nope. Just a second. Okay. And how does it work on the higher frequencies? So on the lower frequencies, it's pretty easy to make a circuit work, I think. And as you get higher and higher in frequency, less and less so. I heard everything on bands A, B, and C. So A band is the broadcast band. Heard stations WBZ, it's our Boston Clear Channel station. I heard plenty of shortwave at the B band. I heard shortwave and ham signals in the C band. The D band, I didn't hear a thing, but that's not uncommon for the gain for a very basic radio to not be that great, and you'd have to really look for local signals. But it works, and not only that, let me turn it on again. That initial problem I had where it was just very, very difficult to get any sort of tuning, and that there was this really, really loud hum instead of the quieter background hum that we heard earlier. That's been fixed. So there was our hum again. And it's not too bad. Yeah, not too bad at all. So, and then lastly, we now know, so the parts that went in here are all so much better than that were in there before. There were parts that had plus or minus 10% in the tolerance. The parts that went in here are plus or minus 2. We replaced all the ceramic capacitors with film capacitors. All the tubes, thankfully, are new. All the wiring is new. All the solder joints are done very well because of yours truly. And we've replaced the wooden case with this wonderful outfit. We've made it cosmetically easier to use. We've replaced it with knobs that roughly all match. There are a couple of things that remain to be sorted out. Like, yeah, I'm kind of not liking how that's going all the way there. See how that goes right out towards the edge. That's not too bad. We can certainly live with it, and we're going to have to live with it, because this stream is my last stream for the year, and it's certainly going to be the last one out of the workshop for some time. My wife and I are taking positions on the West Coast, and the workshop is getting packed up. In fact, right behind me are a whole stack of boxes of everything. I couldn't even show you the parts of the tools because they're already boxed and going. So essentially, I've had 2 consistent viewers, and to you both, I really thank you very much for watching along the way. Having an audience for this has been a real delight, and I hope you've enjoyed it. And I also hope that, aside from what we talked about from the technical aspects and everything like that, that as a demonstration of craft, that it helped scratch an itch you might have for doing the same. And I look forward to anything you may create and be able to share with others online as well. It's the 27th of December, and I think for us all, it's been a very difficult year, and I'm looking forward to better times ahead. There's still some work yet to do for us all, but I wish you all very much a happy and healthy 2021. As much as I say that, it sounds so bizarrely in the future and like we should be in flying cars. But for this moment in time, and with you here with me at the bench, just getting a little bit of some 60s vintage vibe again, I thank you, and good night, and Happy New Year.